Okay, I think we are live. So yesterday we were discussing about object oriented programming. I think we have discussed about the last thing, that was the object oriented programming में हम like I think we were on shallow copy and deep copy. And one thing I forgot. Okay, just I have commented on the video. So let's move with next discussion. Okay, we were on constructors. We have like seen the default constructor, parameterized constructor, copy constructor. Okay, move constructor and convergent constructor, we will see them later because they are little advanced. We know about something. So okay, we got the thing. This is work fine. Constructors, I have defined the constructors: explicit, implicit, parameterized constructors, copy constructors. And implicit copy constructor, I have done this. A single parameterized constructor, the conversion constructor. So should we okay, the conversion constructor is kind of, it will convert automatically data. Okay, now we are at that point that we should learn about type of initialization. Let me give a second. Okay, now we know about class, we know about objects, we know about constructors. Now let us see about types of initializations. Okay, we have different type of initializations. We have class, base class here. Okay, now we have public, and we have some data member like index. Okay, this is our class, and I have to like, let us create an object of our class. Okay, let us create an object of our class, that is base class का एक object होगा, object 1. Now if this is default initialization, default initialization. What is default initialization? Where we need not to pass any argument to our constructors. Like this is default or initialization, means the initialization done by default constructor. So this is default initialization. Okay, now we have direct initialization. What is direct initialization? Like if we require any base and object 2, and for example we have a constructor base and it requires some int n, that is 0, and we are going to pass this dot x will be n. Okay, so we have this kind of initialization. Now if we are initialize object 2 by passing some parameter at the time of declaration. Okay, we are declare our object 2 and we are initializing it at the time of this declaration. It is known as direct initialization. Okay, or direct initialization. Okay, now we can have list initialization. Okay, we have direct list, it is direct initialization. Now instead of passing the parameter in this curly braces, we pass the parameter in a list. Okay, in a curly, this is parenthesis, we pass all the parameter in a curly braces, that is a list. Okay, so that is why that kind of initialization called list and direct list initialization. That is base object 3, and instead of this params I am passing a list, and that list will be of parameters. Okay, it is like 7. Okay, it will run fine. Okay, it is not a vector. Okay, now okay, I think I got what is inside. If you passing this inside a parenthesis, then it will treat, okay, who is this? Okay, then it will treat it as a parameter. It will treat as either a vector or something. So we need not to write here parenthesis. Now there will be compilation, I think there will be no error. Yes, now this kind of initialization is in direct list initialization. Here we do not pass argument in the parenthesis, instead we pass a list. Okay, this is list initialization. Okay, now we have copy list initialization. Copy list initialization, okay, we have a base, we have an object 4, we can initialize this by passing parameters. This is a copy list initialization. Okay, this is direct initialization and this is a copy list initialization. Here we have copy list initialization. Why this is a copy list initialization? You remember, if we have to create a copy from an object, then what will happen? Object 5 will object 3. Okay, so the same thing happening here. Okay, why it is copy list initialization? Let me, okay, basically what happens here is just it will create an object, anonymous object with this 7, and then it will call the copy constructor and assign all the variables that are presenting here inside this object 4. Okay, you are not getting it, I hope. Let us just count. And constructor called. Okay, here we call the constructor. Okay, here we call the constructor. Whenever an object is initialized, either it is anonymous object or any kind of object, we will get this function, this statement will execute. Okay, now I am defining our copy constructor also. So we have base address of object, so just I'll copy the this dot x will be object dot x. Okay, this, and whenever this constructor called, I have to just print a copy constructor called. Okay, this is main motive. Now let us see, now I am going to run this code. Constructor called, constructor called, constructor called, and constructor called. So here what is happening is, for this object this constructor is called, for this object it is direct initialization, this constructor is called, for this as well this constructor is called, and for this we have a copy list initialization. So here the copy constructor is not calling, because copy means we are copying. Actually let me show you a thing. Okay, and we have abjgraph reference. Okay, it is due to reverse, it is due to we have a return value optimization, that is why it is not coming. The things happen here is, whenever we found that list here, it will create an object and then it will transfer the ownership of that object to this object. Okay, that is why we called it copy list initialization. I'll explain to you in a while. Like I have written, okay, let me see, I think I have written something here about conversion constructor, not conversion constructor, about initialization. Okay, so it is copy list initialization. The point is for now you just remember it is copy list initialization. Now we have a implicit conversion or conversion constructor. Okay, we can initialize our object one more way. There is one more way to initialize it. Base, it is like quite base object 5. We can initialize if there is only single parameter 5, there will be no error. Okay, there will be no error. And what is this? What is this? When you call this function, okay, 5 times constructor is called, lekin what kind of constructor, what kind of things, like what kind of initialization is happening here? This is plain object and just we initialize an integer value into this object, but the data type of this object is base and data type of this literal is integer. Like it's like we are doing this stuff, string s is equals to 56. Okay, now string, the data type of as is string, but the data type of this literal is integer. How can there is an error, but in this user defined classes there will not error. Why there is not error? Because if you pass a single parameter, if you have a single parameterized constructor as I have in this case, what it will do, by default it we call it as conversion. If you have a single parameter, then our compiler will see, okay, there is only single parameter, so it will create an object, it will initialize an object with this parameter, and after the initialization of that object it will transfer the ownership to this object 5. Okay, so we call that particular method is conversion. So what is a conversion constructor? Here this constructor work as conversion constructor. Okay, conversion constructor. So when you have a single parameter and it is not explicitly defined, like there is no explicit keyword, explicit. Okay, now if I have this explicit keyword, now the conversion constructor we cannot define like this. Okay, now there is not any kind of error. Okay, I have base. Okay, it will work as conversion constructor, it will work as conversion constructor, and when I am going to compile this, it will compile without any error. Okay, now to make this conversion, like I just want that this thing is not appropriate, this thing is not like advisable to do in your programming. So what we have to do, our single parameterized constructor, that it should not convert the values. For this I think we write explicit. When I write the explicit beyond the converter, then it is illegal. Okay, now by just adding this explicit keyword with your constructor, single parameterized constructor, we basically switch off the features. What kind of feature we are switch off? We features this conversion constructions will not happen, and the copy list initialization will never happen. So that is why I am telling to you like type of initialization is quite relevant, because if you type the explicit keyword just before your constructor or conversion constructor, so you can't do the conversion, this kind of initialization you can't do, and you can't do the copy list initialization. In case of explicit constructor, we can only initialize our object by direct method. Either this is direct initialization or direct list initialization or default initialization. We can't do the copy list initialization or conversion. Okay, I think you got it about this types of initialization. Anything? Okay, the first ensure all the base class are not static members or no issue, then it will define the default constructor. We have default constructor. Okay, with explicit keyword only direct and default allowed. Okay, the point to be noted is with explicit keyword with our constructor, then only default and direct initialization is allowed. The copy list initialization and conversion constructor are not allowed. This is the main core point of these things. Okay, so why you use, so if you have any question like why we use explicit keyword, so we use explicit keyword to disallow the conversion construction or conversion constructor and copy list initialization. Okay, now we have single parameterized constructor. Okay, let's go conversion constructor, single parameterized constructor without explicit keyword. Here we have, it will work as conversion constructor. Here listen, implicit conversion, so it will convert the data type implicitly from this 7 to that test. Okay, because it is a literal of integer type and it is an object of this test type. So we have to in C++, if you have to store something in some variable, you should have same types. Okay, so 7 has integer type, object has like test type, so it is not compatible. but our compiler implicitly convert this 7 into this object by creating an anonymous object and transferring the ownership. So this will this process and this constructor is called conversion constructor. Okay, so then we have this is implicit conversion, use of conversion construction. This is copy list initialization, no implicit conversion because using initializing list. It is C++ 11 के बाद हमारे पास ये फीचर आया था कॉपी लिस्ट इनिशियलाइजेशन का. It is also copy list initialization. Okay, but when we do explicit keyword, then the copy list initialization as well as conversion, these both are restricted. So conversion constructor versus initialization. Conversion constructor must be of single argument, while in initialization list it will call corresponding constructor with respect to the arguments. Okay, to avoid implicit conversion, use explicit keyword. Here we are using explicit keyword and यहाँ पर एरर आएगा, स्टिल एरर बिकॉज एक्सप्लिसिट अलाउ ओनली डायरेक्ट प्लस डिफॉल्ट इनिशियलाइजेशन एंड डायरेक्ट आर टू टाइप्स, डायरेक्ट और डायरेक्ट लिस्ट. इनिशियलाइजेशन लिस्ट. नाउ इनिशियलाइजेशन लिस्ट वी हैव टू काइंड ऑफ लाइक दिस इज टाइप, दिस इज देखो we are initializing objects, so we have just see the how we initialize objects. Now we can define our constructor by two methods, like we have class base and we have public, and we have defined public int x, okay, and int y. Now we have to initialize these. So to initialize the to allocate the resources inside the constructor, we have two method. The methods are, okay, the methods are either have parameter and initialization and we have uniform initialization. Let me explain to you what these are. These are base value and you got int a and int b. Okay, if you are initializing your data member inside your function body like this way, x will be a and y will be b, this is kind of uniform, I think uniform na, parameter initialization. This is parameter initialization. Okay, this is parameter initialization. Okay, this is not uniform, it is parameter initialization. Okay, parameter initialization. Okay, so what's going we can initialize our object in any order, and our data members there is no kind of order preferences. As you like here x, you just define x like you are just putting the value of a inside x. So according to this order, like first this statement will execute, then this statement will execute. So first x will be initialized and then y will be initialized. Okay, but in case of uniform initialization, what we will do is, instead of allocating the resources in function body, we have a list, initializing list. We have this, here we define our functions like x, a and y, b. This is uniform initialization. Let us read about what I have written before. This is parameter initialization, this is uniform initialization. Strict type checking, restrict narrow conversion, like it has some extra feature. This kind of initialization has some extra features. Okay, I'll tell you those feature in a while. Order of initialization according to the declaration in class. Like if we declare this is, okay, if we initialize the member here using then top order matter, you are seeing this. Okay, uniform initialization is a parameter, and okay, parameter, okay, I just got something. This initialization, uniform initialization is not work, I was wrong about that. If you are initializing variable here as the parenthesis, that is normal, and if you use this kind of, then there will be uniform initialization. Okay, correct me, I think this would be okay. This kind of initialization is parameterized, and this kind of initialization is uniform. So this initialization means uniform initialization has some features. What are those features? Strict type checking and restrict narrow conversion. There will be a strict type checking, and it will work on kind of, I don't know about it because I have skipped this part. I just know about uniform and normal parameterized. Like if we are defining our data member in this method using initializing list that we are defining here, then how the data member are got resources? Let me explain to you. The order in which they are defined in the class, they will get the resources according to that order. Like here x is declared before y, so no matter how you are like if you write y and then write x, okay, and you write x, you can do parameter or you can do normal. So I am just using this. Okay, since you have written y before than x, but in this kind of initialization x will get their resources first, because here the member will get the resources according to their declaration order. X is declared first, then means whether you have write x is at first or at last in this list, it will get resources at first. Okay, let me explain to you how it is working. एक डेमोन्स्ट्रेशन करने हैं, डेमोन्स्ट्रेट करते हैं इसको. लेट मी जस्ट डेमोन्स्ट्रेट टू यू. मान लो मेरे पास एक ही वैल्यू आ रही है इंट n. अब मैं x के अंदर a वैल्यू डाल रहा हूँ और y के अंदर a प्लस प्लस डाल रहा हूँ, a की वैल्यू प्लस प्लस हो रही है. अब देखो इन दिस केस यहाँ पे देखना कि a की वैल्यू जो भी मैं पास करूँगा, फॉर एग्जांपल बेस एंड ऑब्जेक्ट, मैंने यहाँ पे 5 पास करी. ओके, आई जस्ट 5 आई हैव पास द वैल्यू, द 5 विल अपीयर हियर, एंड इफ 5 6 5 5. Okay, if the initialization of x, like if this initialization is this operation is performing at first, like initialization of x is going to happen before y, then what will here, x will initialize with 5 and the value of a is incremented, and then y initialization will happen and the value in y is 6. Let me just print the value of count object dot x and object dot y. Just run it and we'll see the 5 and 6. Did you see the difference? Now if I am just changing the order, I am just changing the order, I am doing nothing, then both the values should be 5. Let us see. Okay, both the values are 5. Okay, that means order of the declaration is matters. But if you declare normal, like x की value a plus plus and y की value a, here the order of declaration doesn't matter. The matter is in which order you have initialized. Like if you have initialized x first, then x will be 5 and y will be 6. Okay, or if you initialize this order matter 5 5. Okay, in this case the order of inside our function this order matters, or in that previous case by initializing list the order of declaration matters. Okay, like if there is something kind of 5 5 is appearing, if I change the order of, let us change this order, comma, now run, order will be same 5 5. If I change this order of declaration, then the value will get got the different value. Okay, so that's is difference between initialization list and normal initialization. Okay. Okay. Move constructor is quite of to explain move constructor I have to explain you return value optimization and named return value of optimization. And move constructor is not, but it is a topic, like it is much advanced topic. We will discuss it later, but I have to revise this. I'll revise it later. It is 3:52. I have to do live stream of driver seat. Okay, that's the difference between new and placement new. Did you know about new or placement new? Okay, let me explain to you what is new and placement new. When we have new, it is used for dynamic memory allocation, as we all know. But in a new, we do not give the space. We just tell, by just using new, we are just telling him, just I have this data, just initialize it into location. Okay, but in placement new, we are providing data and we are providing space. Not just store the data, just store this data inside this space. We are providing space as well as our data in placement new, and in new we just provide our data to just initialize it. Here we are not concerned about the memory location. Let me demonstrate to you. Int main, we have kind of return 0. Okay, we have pointer character star object. Okay, so like I have to explain, let me think about some example. 1 byte, I'm just okay, for example, we have a class, base class. Okay, I have a base class and public, just simple class, base class. Okay, I just want the member. Okay, and I have to create an object in a normal, like I am creating just base. Object 1 is new base, that's it. Okay, no suitable constructor to form the base. This should, because new always return the memory address. Okay, that your data is stored in that location. Okay, so that is normal method. It is normal new. Okay, it will allocate the memory just and return the address of that memory where we have initialized this object. Okay, and this is how new works. New base. So what new will do? New will initialize this constructor in the heap memory. It will initialize this like it will give the how I tell you, it just create in this method of new, it will just in the heap memory, it will just create a memory and put our data that is created by this constructor or this object will be placed there, and it will return the address of that memory. So here we will get the pointer. Okay, we have to store into pointer because it will return the address. Now in the placement new, we are giving address itself. So we are storing base. So what will be the size of this base? We have to create the size of this base. Okay, let us we have created memory character star and is character star memory, and that will be new, and that will be character, and it will be the size of I'm just vague, let me okay, I just create a size of buffer. Okay, this is the time I have to just create the memory character star buffer, that will be the size of base class. Okay, now we have created the memory. In that buffer location I have to place my object. I have to initialize my object in this location, in this buffer. Why I choose this character? Because the size of character is 1 byte. Okay, so for example, if the size of base is 8 byte, it will initialize 8 byte, and the size of each character is 1 byte. So overall, due to the size of this one block of character is 1 byte, I am initializing this kind of thing, this kind of stuff. Size of buffer, it will create a buffer array of size, like I have put here 2 byte, so it will create the 4 byte size. If I have used here int, then it will create the 4, the size of int is 4, and the size of total size I required is 4. It will create the 16 byte. So okay, it will create the 16 byte memory. Okay, but we don't need this, we just need the size that is equals to this base size. So that's why I am using character here, and it will be the size of base class. Okay, now I have to convert the type of this character star to a star. Okay, it is basically just a memory allocated. Okay, now I have to convert this type to base star buffer is equals to static cast or normal I'm changing a type conversion of to base star buffer. Okay, now buffer will be equals to, I am not getting, I have to revise this thing. This is the placement new buffer. The placement new is kind of this is new, just use the parenthesis and provide here space, that will be the placement new. Okay, just that's it. I forget about many things I have to. It's 33 minutes.